In this lecture, I'm going to present you our ISWC note paper, Audio-Based Onset Detection Applied to Chewing Cycle Segmentation. First, we explain the problem of chewing cycle segmentation and how it can be solved using audio data from chewing activity. On the upper half of the slide, you can see plots of chewing sequences, so audio from participants chewing from intake to deglutition, here and here. Let us listen to two different food types. First, potato chips, which is a louder food type. Now baguette, which appears to be more quiet while chewing. The goal of chewing cycle segmentation is to partition the chewing sequences into all events of mandible closure and opening, so-called chewing cycles. On the lower half of the slide, two chewing cycles are shown. We aimed at obtaining the segments of each of these cycles using signal processing techniques on the chewing sequence here. We used rhythmic and onset structures within the chewing sequence to obtain chewing cycle segments. Starting from the vibration signal of the chewing sequence, we window and transform the signal, compute a novelty function, which is either an energy difference function, a spectral flux novelty obtained from the spectrogram, or a predominant local pulse curve, which measures tempo variations in musical pieces and corresponding beat positions. It turns out that this principle can be transferred to chewing cycle segmentation. After computing peaks of each curve, we obtain chewing cycle segments. We compared and evaluated the three different novelty curves using a dataset of 7 participants who chewed 6 food types: 3 loud, potato chips, apple and carrot, and 3 quiet, baguette, beef jerky and cheddar, with a total number of 9,818 chewing cycles. We recorded the data using a vibration sensor wired to a headphone jack, displayed here, which was plugged into an Android smartphone and placed on the head to assure bone conduction. As an evaluation measure, we used a 50% jitter allowance measure and recorded precision, recall, and F measure. On this slide, precision recall curves obtained from all 3 techniques are shown. Best performance is found on the top right corner of each plot. On the upper left side, the PR curve of spectral flux onset detection is displayed, where one can see that this algorithm performs well, especially for louder food types, as it works with differences in the spectral domain. On the upper right, the PLP beat tracking algorithm is shown, where all food types perform with precision and recall of at least 0.7. For comparison, the energy baseline algorithm is displayed in the lower 2 plots, where peak picking was performed in an online fashion on the left side and in an offline fashion on the right. Still, both spectral flux and PLP beat tracking outperformed the energy baseline technique. Finally, we evaluated PLP beat tracking and spectral flux onset detection with a leave one participant out cross-validation. For beat tracking, the range of possible tempi, which is a parameter of the PLP computation, is varied in the LOPO cross-validation. The average F measure over all participants is 0.83 for the PLP beat tracker, here on the left-hand side. For spectral flux, the relative threshold of the adaptive peak picking algorithm was varied. The LOPO analysis resulted in an average F measure of 0.76 here. We analyzed the applicability of 2 important algorithms from the field of music processing for the task of chewing cycle segmentation. The algorithms spectral flux onset detection and PLP beat tracking offer the possibility to segment audio chewing sequences into cycles. During LOPO cross-validation, we obtained an F measure of 0.83 for PLP beat tracking and 0.76 for spectral flux onset detection on our dataset measured using a bone-conducting vibration sensor. In general, our analysis shows that it is possible to segment chewing sequences into cycles by using the audio signal only, which offers the possibility to analyze chewing with devices where only microphones or other audio sensors are available. Spectral flux onset detection performs fair and particularly well for louder types. PLP beat tracking offers a good performance, especially when participants chew with a homogeneous and more or less constant chewing frequency. Thank you for your attention.